This project is implementation of a self-navigating robot. A single-board computer Raspberry Pi is selected in this project, which is responsible to transfer data, detect the surrounding environment, and drive the omnidirectional robot. With PiCam attached on the board, image data can be acquired easily. A convolutional neural network is applied to perform object detection, which will allow the robot to interact with the environment. To reduce the neural network computing time, the image taken from the PiCam will be encoded and sent to the laptop via Wi-Fi. The laptop will generate instructions in accordance with the output of the neural network and send it back to the robot. The robot can recognize the object, measure distance between the object and itself by a customized image processing algorithm. Moreover, performing collision avoidance with this result. So the neural network adopted in this project is YOLO version 3, and the input of the network is 416 by 416 by 3 image, and the output is an S times S and B times 5 plus C tensor. S times S means the grid cell we divide by the image. The B is the number of the anchor in the cell. In other words, predicted bounding box. So for example, in this project, we got 13 by 13 cells, and the B is 5. That means each cell predict 5 bounding box. So in the end, we will have 845 bounding box. But after we suppress those with low confidence or the overlapped bounding box, we will finally get a result. So here, this is the result we create from the model. This is a music video, and you can see some objects are not detected correctly, like because I set the threshold quite low, for like just 0.1. So this is how I measure distance between object and the robot. I use this map drawn by myself and set the region of interest, do the perspective transformation. By this result, we can measure distance in terms of the x and y location on this image. This is the output of the neural network. So I take this point and plot it to a new image as a red dot, and then in next slide you can see we do the perspective transformation, and now we can calculate the distance in terms of its x and y location. But here we see there's more than one object here, because the perspective transformation enlarge this dot. But it doesn't really matter. We just take the smallest one to make the decision. So this table here shows the distance we measure and the distance we expected to be measured. The error is around 2%. Yeah, this is not very large, but I want it to be better, so I use the curve fitting algorithm on Excel, and so here is the result after I applying the curve fitting equation. We can see the error drop from around 2% to 1%, and I think that's good enough for this project. By the algorithm build, the robot is going to trap itself in the surrounding field. And thank you for listening. This is the end of the presentation.